So thanks for everybody sticking around. We're talking about the term file-based video in the IT network. Let me see some hands. How many are broadcasters in the room? All right. How many are IT engineers? Man, would you ever think that those two would actually be in the same room together? It's kind of interesting. In the earlier presentation, I talked about convergence. We're actually seeing it, and the discussion today is going to talk about the infrastructure, including MXF and some technologies that we deal with on a one-to-one basis just about every day. Let me introduce our panel. Of course, I'm O'Brien McKinley from Globecomm, and we've got next to me Mr. Alan Popkin and Mr. Tom Ohanian from Cisco. Talking about Alan, since 2002, Alan's been the Director of Technical Operations and Engineering for KLCS in LA. Where there, he's redesigned the entire station and to implement state-of-the-art digital broadcasting to the entire Southern California LA DMA. And datacast to over 1 million students, teachers delivering digital content services to an educational audience. KLCS has been 100% file-based environment since 2003, one of the leaders of that, and received Broadcast Engineering Award for Engineering Excellence for the effort. Alan's also involved with PBS NGIS, which is Next Generation Infrastructure. Interconnection, yes. As a pubcaster, I am very familiar with that. I was at the PBS side on the NGIS committee, where the NGIS at PBS is a national file-based delivery system, as well as a peer-to-peer file sharing effort amongst PBS members. He's designed new mesh control file-based systems for other stations, as well as multimedia infrastructure for college and universities. Also with that, thing you didn't know about Alan, he's also a musician and has a couple albums under his belt, and if you ask him later, he'll tell you some of the groups that he's played with and still plays with. So about Tom, he's a member of the digital media strategy team at Cisco Systems. He was one of the founding team members at Avid Technology, and we've always heard of the Avid Media Composer and Film Composer. Well, you have him to thank for that. Is that right?
It was a fun time. With zero revenue and zero customers and no products, so go build a company.
Exactly, and we need it tomorrow. Along with as part of the co-invention team for the Media Composer and Film Composer, also did multi-camera systems. He started as a broadcast engineer at the age of 19 and has an extensive production and post-production experience. He's an Academy Award winner with two-time Emmy recipient for scientific and technical innovation. So I think we've got a very first-class panel here to talk about this. Let me turn it over to Alan, who's going to give us his spiel. Then we'll hear from Tom. We'll open it up for questions.
Anyway, this is kind of like a very abbreviated view. Recently SIMTE engaged me to do 4 or 5 cities, about an 8-hour seminar on this topic. And you're going to see about a 10-minute version of 8 hours, so we're going to be moving rather rapidly. That's why it's from 80,000 feet. A couple of things, very few things I want to talk about is how did we get here? Why should we change? What are the issues, and what the hell is MXF? It's a word that we use, it's a buzzword that everybody uses and nobody understands. Anybody here actually know what MXF is? Well, you've taken the seminar. Because generally, when we get to MXF, I'll talk about it, but there's at least 7 SIMTE documents and about 12 other papers you have to go through. And then if you take a hex editor and actually go through an MXF file, you have a vague understanding of how the damn thing works. And it's not quite what you think it is. Okay, well, we started with tape-based workflow. It was really simple, it was really stupid, it was really easy. You put a tape in a camera, you recorded it, you put it in an edit bay with multiple tapes, you edited it, and every step of the way, you multiple tape ingest, multiple QCs, And I don't know if anybody remembers tape, but if you try and find a tape, it was never there when you needed it, and then you had to go through 50,000 tapes. If you think finding a file is difficult, try finding a videotape. It's inefficient, it was time and labor intensive, and QC was required at every single stage. Every time you made another tape, somebody had to look at it to make sure it actually stuck on the oxide. And then that was only for a while until you ran it a couple of times, then the oxide fell off and you had dropout. So we got to this concept, ingest once, use anywhere. Brilliant. Just, okay, we only have to do it once. Well, unfortunately, that's a nice theory. It doesn't quite work that way. There's a lot of ouch points in file-based workflows, and no one ever talks about them. No one ever gives you a heads up saying like, oh, file-based workflow, it's easy, just do this, this, and this, but no one ever tells you where the headaches are, and no one ever tells you what questions to ask. The problems, fire interoperability, and one of the things is compliance with a standard does not mean that it's interoperable. You can be MXF compliant and have absolutely no way to play that MXF compliant file on another MXF device. Now it's just seems mystifying that they would write a standard that's not a standard, but it has to, the problem with MXF is that it's you shall do something, you should do something, and you may do something. Now there's very few shalls, there's a lot of shoulds, and there's a hell of a lot of mays. And every manufacturer decided to implement it a completely different way. Like take something simple like indexing. Indexing allows you to search a file to find a particular point. Well, if you're recording a file, you can't write that index before you record it because you don't know how long the file is. So most recording devices write the index at the end of the partition. However, server vendors who are playing out files write their index in front of it because they know exactly how long it is. You may not be able to search a file that's been recorded in another server. It just doesn't work. It doesn't know where to look for it. The other thing is that every workflow is different. Like my particular workflow is designed for my station. Your particular workflow would be designed for you. It may not have the same requirements. It may not have the same file standards. It may not even have the same. It's certainly not the same equipment, not the same way it works, not the same set of business rules. And the other problem is that there's a lack of talent out there. There's people who understand media, and there's people who understand IT. There's not a hell of a lot of people who understand media and IT. And the classic example is you ask somebody in video to buy you a router, and you ask somebody in IT to buy you a router, and you're going to get two different boxes. And nobody says, I bought a router. And the trouble is we don't speak a common language, and the video people have a tendency to distrust and hate IT, and IT thinks everybody who understands video is an idiot. So it's a wacky world, but until we build those bridges, and one of the reason I teach these seminars for simply is to try and build those bridges. And the biggest nightmare is ancillary data. And everybody says, what the hell? Video is actually the easiest thing to do in files. Audio is tougher, and ancillary data like closed captioning, Nielsen, watermarking, parental ratings are almost impossible to do in files. And people don't understand why until you start getting deeper into it, but it just is. And the other thing is transcoding, because what happens with ancillary data is you're going to grind a file. You're going to say, okay, I'm going to take it from an MPEG to blah, 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 so many megabits, and turn it into a 264. Well, that's the video. And you say, okay, I'm going to take 16 channels of audio and grind it down into this, 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 and this for this audio. But then again, the transcoder has no way of knowing. Most of them don't even deal with closed captioning. They just throw it out. Most of them don't deal with Nielsen watermarking. They just throw it out. None of them deal with parental ratings. They just throw it out. So you have a perfectly usable file that has none of the ancillary data that you need to make your enterprise work. But you've spent a lot of time, money, and effort, and all of a sudden the end product is totally useless to you, and you're wondering why. Key to implementing file-based workflows is business rules. There is no way in the world to manage multi-hundred terabyte, petabyte-sized volumes manually. You think you're going to have some guy or woman sit there with a whole list and saying, I should delete this file? There's no way to find it. It's like, okay, here's 7,000 files to delete today. You think they're going to make a mistake? Absolutely. They're going to delete ones you need, and they're going to leave ones you don't want. So business rules are based on metadata. And metadata is where the true nightmare comes in. If you think ancillary data is a nightmare, metadata, everybody understand what metadata is? It's like, you know, in the old videotape days, you always hated when the metadata got stuck in the capstan. You know? It's just data about data. It's the label. It tells you where it is and what it does and, you know, what track is doing what. And you know, MXF, they came up with the idea, hey, I got a great idea. We'll have MXF, and that'll carry the metadata in a header in the file, so that it will never be separated. Nice theory, because there's different places to put metadata. One of the key things in MXF that I found way too late in the system design was that the SMPTE committee that designed MXF left out one little detail. There's no place in an MXF file to put an audio track label. You can tell, the structural metadata will tell you whether it's AC3 or PCM and what bit rate, but there's no place to put the metadata to say, this is English stereo, this is Italian. You know, there's no place to put it. So you have no track labels. So it's like having a track sheet in audio that's blank. And that's what MXF manages to accomplish for us. And the other trouble is that MXF is not widely understood and certainly not uniformly implemented. Like in the P2 cards, they close the partition every 2 seconds because they're recording constantly and they want to be able to roll it back. In a typical server, you know, where you're playing it back, it's every 20 minutes. And again, the indexing, where the metadata is, you know, and you know, silly things about MXF. It's all contained in what's called a generic container, which is neither generic nor a container. So it's a wacky, wacky world out there. This is the last slide I got. I can normally spend 4.5 hours on this slide, but I'll spend a couple of minutes. This is MXF. This is the package of complexity. And so you've heard the buzzwords OP1A, OP2B, blah, 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 blah. Operational patterns, okay? And of the 9 that are out there, there's one that is uniform, that's been implemented by vendors. It's OP1A, the one in the upper left-hand corner. And you have the material package, which is essentially the track sheet of what's in there, and then you have the file package of what's there. And essentially, if you have OP1A, you can have a set of video and a set of audio and a set of metadata, theoretically, and you should be able to play it out. Now, I'm involved with the PBS non-real-time effort, and they came up with a package called ASO3 PBS shim. You know, application specification 03 PBS shim. And they somehow had the dream that server vendors were going to adhere to this. And they were going to make their servers that were 5 years old forwardly compatible to this package. And lo and behold, none of that happened. So after developing this whole standard, they now have to transcode every single file that they ship back to the old files. So it was a noble effort, a great idea. They were trying to create a type C file, for those of you who remember tape, a type C file that could play on every server. Didn't happen. It probably will never happen. OP1B has some really interesting uses. I don't know if we can talk about it real quick, but that's where you can gang a package. And I'll give you an example now. We won't take it as a question later. Turner. Turner owns Gone with the Wind. They have at least 40 versions of Gone with the Wind in every single language known to man. So they have 40 files, 40 sets of video, 40 sets of audio, all in separate files. The video is identical on every single one of them. Well, in OP1B, what you can do is you can take a material package, you can take multiple sources. So you can say, okay, this is always the video, and here's 40 different languages underneath it. And if I need it in Turkish, I'll just derive the OP1A from the OP1B. I'll take the video and the Turkish audio. You know? Now the Holy Grail is OP3C, where theoretically you can take every single piece of an asset that's ever been created. This is theoretically, I don't think it'll ever be done, because we have enough troubles just getting to OP1 and B, and put it in a giant package, store it somewhere, and just set an instruction set saying, I need Gone with the Wind in Turkish with Italian subtitles with Czechoslovakian ratings. And it'll just spew it out for you. So that's the idea of MXF. And again, it's the Holy Grail, but it'll never happen. It just will never be done. Because the complexity of trying to play it out, you can't play it out. There's no server that can actually deal with the complexity of OP3C. They have enough problems dealing with the complexity of OP1A, which is not complex at all. So that's it for 80,000 feet. I know we're running a little late. So the idea of this one, I like interactive sessions. I hate just death by PowerPoint. You can sit here all afternoon. It's like, oh yeah, he said something. So the idea with this is I'm just going to throw these ideas out there, and after Tom's presentation, we'll just throw it open for questions, because I think that's the best way to try and understand this stuff, because there's just no way I can cram 8 or 10 hours worth of material into 10 minutes. But thank you.
So the good news is that we have a lot of content. Al and I have a lot of content in our individual presentations. We blasted this down to 7 slides each. So that's the great news. You only have, and that's including the title slide. Hopefully we'll have some great questions as Alan and I hope. But in the end, one of the things that I want to talk to you guys about and ladies about is some of the changes that we're tracking, some of the things that we're trying to help herald along, and some of the trends that we're seeing. And again,